All right, in this video, I want to take a look at some limits as x approaches infinity, and just look at the different scenarios that can happen. Just look at some examples. So we're going to go through, I think, 4 or 5 examples, 5 examples. All right, so let's take a look at this one. So when we have a limit where x is approaching infinity or negative infinity, the first thing we want to look at is what is the highest degree of the numerator and the denominator if it's a rational function. And so the highest degree in the numerator is 2, the highest degree in the denominator is 2. Remember, if they're the same, then we need to do a little bit more work. So if they are the same, what we're going to do is we're going to take that variable to the highest degree and we're going to divide every term in the numerator and the denominator by that variable to the highest degree. So what we're going to end up with, we're going to have the limit as x approaches infinity of 4x squared divided by x squared plus 3x divided by x squared divided by 5x squared divided by x squared minus x divided by x squared and plus 2 divided by x squared. Okay, so now what we're going to do is we're going to evaluate these. We're going to reduce them if we can. And so we're going to have the limit as x approaches infinity. The x squared and x squared here, those will reduce. So we're just going to have a 4. Here, the x and the x squared can reduce. And so we'll end up with, rewrite that. We'll end up with 3 divided by x. And then here, in the denominator, x squared and x squared will reduce. We'll be left with 5. An x and an x squared can reduce. We're just left with negative 1 over x. And then the 2 over the x squared, we can't reduce anything. It's just going to be plus 2 over x squared. Okay. And so now, if we look at each part of this, which from the theorems we learned about with limits, we know we can break them up. We're going to look at and evaluate each part of this as the x approaches infinity. So 4 is just going to go to 4, right? The 3 over x, 3 divided by infinity, that's going to go towards 0. The 5, just a constant, that's going to go to 5. The 1 over x is going to go towards 0, so we're going to have a minus 0. And then the 2 over x squared is going to go to 0 even faster. So this is just going to be plus 0 here again. And so 4 plus 0, that is 4. 5 minus 0 plus 0, that is 5. And so that limit is 4/5. Let's take a look at another one. Here we have, oh, I think let's scroll away from it. There we go. Oh, yeah, a little bit more. There we go. The limit is x approaches 0 of x to the third plus 2x minus 1 divided by 6x squared. So here again, we want to look at since we're going to infinity, we have a rational function. We want to look at the highest degree. The highest degree in the denominator is 2. The highest degree in the numerator is 3. Since the highest degree is in the numerator, that means that this is going to plus minus infinity. We got to figure out which one though. So let's look at what each part is going to do. Well, if we take infinity, we raise it to the third power, that's just going to be positive infinity. This other stuff right here, 2x minus 1, is going to really have no comparison to how large this number gets. So we really don't need to worry about these so much. We just need to worry about that largest one. You can still think about it. Okay, well, this is going to be positive infinity. 2 times infinity is going to be positive infinity. And the minus 1 is insignificant compared to these large numbers that we're looking at here. And so this is going to end up being positive infinity in my numerator. Let's look at my denominator. Well, really, that's fine. Sometimes I just like to look at the sign. So let's write it like that. This is going to be positive up here. We know it's going towards infinity. All right, so now if we plug in our positive infinity into the 6x squared, you square infinity, it's just a larger infinity. You multiply it by 6, it's still positive. That's what we're worried about. So it's going to be a positive divided by positive, which means we are heading towards positive infinity. let's take a look at, oh, so here, all right, we didn't lose it. We have x is going towards infinity. The highest degree in the numerator is 2. The highest degree in the denominator is 3. Oh, well, if the highest degree is in the denominator, super easy. This is going to be a larger number down here than what we have up here, and it's going to continue to grow and grow and grow and grow. And when you divide a number by a number that's larger than it, it's going to head towards 0. And so that's going to be our limit there. No real work to do on that. You get 2 or 3 more. All right, here we go. So we got our limit, x approaches infinity. Let's look at our highest degrees. Highest degree of 2 in the numerator, highest degree of 1 in the denominator. So that means this is going to head towards positive or negative infinity. We just got to figure out which one. Okay. And so let's see what's happening. So we're going to plug in our infinity here. We're going to square it, still positive. Then we multiply by a -2. Uh-oh. So a negative times a positive, that's going to be negative. This really does not compare. It's insignificant. And so we're going to have a negative in our numerator. Let's look at the denominator. We're plugging in infinity into here. 5 times infinity is going to be positive infinity. This -3 is super insignificant. Don't care about it. It's going to be positive. Now, since the numerator is negative and the denominator is positive, negative divided by positive, that's a negative. And so this limit, not sure where I wrote an equal sign right there, this limit is going towards negative infinity. Okay, so we need to look at the sign of the numerator and the denominator. If we determine that it's going to positive or negative infinity, we need to figure out which one by looking at the signs. Okay, interesting though. As an offshoot, what if this was set into negative infinity? Same function. Well, let's think about it. Well, so we got the highest degree in the numerator. So we need to determine what's going to happen. It's going to head towards positive or negative infinity. If we plug in a negative infinity into an x squared, when we square a negative number, it's going to be positive, but then we're multiplying by a -2. So this numerator is still going to be negative. Let's take a look at the denominator. We're plugging in a negative infinity here, multiplying it times a positive number. That's going to be still a negative infinity down there. Negative divided by negative, that's going to be positive. So this is actually equal to positive infinity. So you need to think through of what number you're plugging in, if it's positive infinity or negative infinity, and think about what's going to happen to it when you evaluate it in the numerator and denominator of the function. So pay attention to that. And one last one. It's the same function, but I have changed the sign in the denominator. It was -2x squared plus x over 5x plus 3. And that, oh, well, it was 5x minus 3, but now it's -5x plus 3 in the denominator. We're still going to positive infinity. Maybe we'll look at negative infinity. Why not? So we see higher degree in the numerator than the denominator. So we know this is heading towards plus or minus infinity. We just got to figure out which one. So let's think about it. We plug in infinity into our square. That's going to be positive. Multiplied by a negative, that's going to be negative. This is insignificant. We don't care about it. So what we end up with is a negative in our numerator. We plug in infinity into this x here. A negative times a positive infinity is going to be negative infinity. This 3 I don't care about, it's insignificant. So this is going to be negative down here. A negative divided by a negative, that is positive. So this limit is going to be positive infinity. All right, and now I am interested. So let's see, what if it was negative infinity that we were heading towards? Similar to what we did in the last problem, let's look at the other thing that can happen. Let's just see. All right, so we're going to do the limit as x approaches negative infinity, negative 2x squared plus x over negative 5x plus 3. So we know it's heading towards positive or negative infinity because we look at our highest degrees and the numerator one is larger. We just got to figure out where is it going, positive infinity, negative infinity. Well, plug in a negative infinity to the x squared, it's going to be positive infinity now. Multiply times the negative 2, it's going to be negative. So we know that our numerator is negative. Remember, this x is insignificant compared to the size of that guy. All right, now we're plugging in a negative infinity into this x. It's going to be negative infinity times a negative number. That's going to be positive infinity. So we have a positive number in our denominator. And so a negative divided by a positive, that's going to be negative. So this is going to head towards negative infinity. So not always the case, but in this case, it swapped it. Okay, so that's basically how you can evaluate limits that approach infinity.